Today's lesson is the start of part C. So we're going to get into conditional probability and see how that goes. Okay, the probability that one event happens given that another event is known to have happened is called a conditional probability. The notation we're going to use is exactly that. So it looks like there at the end it says probability of A given that B has happened. So that line, that vertical line means given. Probability that A is going to happen given that B has already occurred or has already happened. So the Titanic, this is all the data from that. I think we might have talked about this one before. Suppose we randomly select one adult passenger, find the probability that the passenger is third class and given that they survived. So we're only looking at the survival folks here. So let's look at this question again. So let me get back to it. Given that it's third class, so we're only looking at survivors. So for this question, this is given. So the given there is basically, we're looking at these guys right here, all of those folks. There's 442 of them. So the given is that you survived. What's the probability that you were third class? So survived is the denominator, not out of 1207. This is only out of the survived. And then the probability is third class would be 151. And then you would type that in your calculator to get the decimal, but that's how you get the answer there. Describe the probability in words. Okay, so and so in words, again, we're only looking at the survived row, right? So, or in words, I like the notation here. Probability is third class passenger, given that you survived. Did we get the same answer? I think we did. 151, 442. Yeah, good. Given that a randomly chosen person survived, there's about a 34.2% chance they were a third class passenger. I like that. Okay, given that a person chosen is not first class, what's the probability they survived? Okay, let's go back to that. Not first class. So, whoops. Let me go back to that. Okay, so not first class would be, sorry. Not first class is all of these folks, right? So given that you're not first class, the question was, what's the probability that you survived? So not first class is all of those, whatever 261 plus 627 is. Oh, wow. So my denominator is 888, right? That's not first class. Given that you're not first class, I keep forgetting the question. What is the probability you survived? So of those, which folks survived? So if I add up those two, 94 plus 151, so 245 over 888. I think should be it. Let's see what happens. 245 over 888, or 27.6% chance. So to find the conditional probability that probability of A given that B has happened, use the formula. So you could be a formula person and use this if you wanted to. So it's a different way of doing this problem. So if we go back to that last one, probability of A given B is A and B divided by B. So in this case, not a first class passenger, so would be probability of not a first class passenger would be not first class is we already added that up. It was 261 plus 627. So 888 divided by 1207, and using the formula says probably of A and B. So this was probably both those things happening: surviving and not first class. Surviving and not first class. So let's get to there. Surviving. So this is still out of 1207. In the numerator would be two numbers. It would be surviving and not first class. So 94 plus 151. if you simplify those fractions, you multiply by the reciprocal, the 12 of 7s end up canceling, and you end up getting the same fraction we got before, 245 divided by 888. I think that's more work to do. I don't usually use the formula, but you're welcome to use the formula. Some people are formula people, and it makes sense, and you can do that. It is included, one of the formulas that's given to you. So if you're a formula person, that's great. Survey about social media said that 69% use Facebook, 40% use Instagram, 32% use both. Suppose we select a US adult at random. Given that you use Facebook, so in this case, we're talking about, let's see if I can get this a little smaller. So in this case, we're talking about given that you use Facebook. So that was 69%. So our denominator is 0.69 or 69%. Out of those folks, what's the probability you also use Instagram? So also use Instagram. So this one I got to think about. I think this is going to be 0.32, right? Divided by 0.69. Let's see what they get. 0.32 divided by 0.69, so 0.64. That's just hard on the brain. You have to think about it. Given that you're a Facebook user, so you have to be using Facebook. 8% of folks, I mean, some folks there did not use Facebook, right, who used Instagram. So you have to think about that for a minute. You can write statements like that if A and B are clearly identified. Otherwise, I really prefer the words there. That just makes more sense. Or I even really like the shortcuts. Probability of I, given that F has happened. That means probably of Instagram, given that Facebook has happened. Independent events are these. What's interesting on this one, and you can write these down, I just think of it as this. For independent events, I think of the probability of A must be equal to the probability of A given that B has happened, and then you just define A and B in the problem. But that's typically, I shortcut that formula a little bit. You can write down the full formula there, but I kind of shortcut it to just that. Is there a relationship between subject taught and handedness? To find out, they took a simple random sample of 100 teachers at an educational conference, like the one I go to. Two-way table summarizes the relationship between the subject taught and the dominant hand. Okay. I wonder if there's any relationship there. Suppose we choose one of the teachers and a sample at random. Are the event teaches math and left-handedness independent? So let's think about this. So we've got, so I'm going to try to use this formula. Probability of A equals the probability of A given that B has happened. If they're independent, that should be true. And we can choose what A and B are. There's no magic to this. So I'm going to use words here. So probability of math, let's say math, should equal the probability of math given that right has happened. In other words, whether you're right-handed shouldn't make a difference if you're a math teacher or not. Same proportion should be both. So what's the probability of math? So we have 46 out of a grand total of 100, or 46%. Given that you're right-handed, so I'm only looking at the righties here. There's 90 of those. So out of the 90, 39 are right-handed. So are those two equal to each other? I don't know. Okay, so 46 divided by 100 is 0.46. That makes sense. 39 divided by 90 is 43%. They're close. I knew they were kind of close. They're not equal. So I don't think those are independent events here. So this is what they did. So they said, oh, they did it differently than us. It's okay. They said probability of being left-handed should be the same as probability of left-handed given that you already teach math. So they tested those two. Those weren't equal either. And so that proves it, right? That proves that these are not independent. They're not independent because they're independent, then the first event has no effect on the second event. Given that B has happened has no effect on the problem at all, which is weird. I don't think right-handed should have an effect. Knowing that teacher's subject math increases, the probability the teacher is left-handed. Ooh, it's interesting. My older sister's a math teacher. She's left-handed. My parents are both math teachers. I'm a math teacher. We're right-handed. Okay. Can you tell when a person who is in the early stages of illness just by looking at their face? In order to help answer this question, 2 photographs of each of 16 people were taken, one after being injected with a placebo, and one after being injected with a bacterium that causes inflammation. Ooh, I hate this study. I don't love this. I don't want to be in it. Then these photos were shown in a random order, except no photos of the same person were shown consecutively. Oh, interesting. I kind of like that part of it. To a sample of 2,945 volunteers. Okay, so the volunteers rated each photo as this person is healthy or this person is sick after looking at the photo for no longer than 5 seconds. So just a quick kind of first impression. Two-way table summarizes the data. Suppose we randomly select one of the ratings for the study. Define H as healthy, S as sick, B as bacterium. Find the probability of being sick given that you have bacterium. Okay, S given B. Let me see if I can get to this. I don't know if I have it. I didn't do this one, I don't think. Okay, we'll just have to talk about this one. Okay, so given that B has happened, so B is bacterium, there's 1,473 bacteriums, folks, and of those, 775 are sick. So you just divide those two numbers. Let's see if I can see that here. Yeah, 775 divided by 1473 is 52.6%. Given that a randomly selected rating was for a person injected with a bacterium, there's about a 52.6% chance that the rating was sick. Part B, oh no, we haven't got there. What's the probability that the person in the photo was injected with a placebo, given that the rating was healthy? So given that you're healthy, 1,730, what's the probability rate? Placebo is 1032. Oh, here it is up top. I didn't see it. So we had 1032 divided by 1730, or 59.97%. Here we go. A sample of U.S. high school seniors who responded to the census at school survey, 87% said they planned to attend college. It's nice. 42% say they felt a lot of pressure because of schoolwork, and 37% said both of these were true. I'm surprised more didn't say both were true. For an selected student at this school, sample feels a lot of pressure because of schoolwork. What is the probability they plan to attend college? So if a randomly selected student at this sample feels a lot of pressure because of schoolwork. So how many folks did that? 40 out of the 42%. So my denominator is 42%. Of those 42%, what percent plan to go to college? So of those 42%, so that'd be 37. Oh, so of those, that makes sense, right? 37% had both. So only the folks who felt a lot of pressure, that's the given, but also plan to attend college, so that's 37% is both. I needed both on top there. That's the and if you're a formula person, divided by, again, the given, which is that felt a lot of pressure, so it's 88.1%. Human bodies aren't perfectly symmetric, that's true. If you measure the lengths of the ring and index fingers on your left hand, your ring finger would be longer and your index finger would be longer, or it'd be equal, and so forth. Two-way table summarizes these measurements. Are these events, index finger is longer and feet are equal length independent? So you would test one. They did probability of A given B should equal the probability of A. So they said probability of index finger, that's your A, given that B has already happened, should equal probability index finger is longer even when B hasn't happened. So that the overall total there, they're not the same. So these are not independent of each other there. Okay, that's your lesson for today.